So for interactions, various papers have quoted that as well. Some need to consider uh, the homogenization and okay. We already did this complete image plasticity work and not seeing any interaction consideration here. So let's go to the ABAQUS and let's use this wise approach. But before that, let's create an interaction property. Uh, Call it concrete steel property or intersection or interaction, right? And here I need to select the tangential behavior to be a penalty based, and I will assume 30% friction coefficient. And yeah, normal behavior. And you can study the theoretical background of this interaction module. Um, After that, I need to find the contact pairs and find the interaction, call it steel concrete, right? And I will call it steel concrete. I will not name each surface and find contact pairs. So we have one bottom steel concrete interaction, and we have top steel concrete interaction, right? We have these two interactions definition here, right? We have surface to surface sliding, and we are not going to do anything else. We are okay with it, and let's only go to check these properties just for the case of um, master surface to be yeah, okay, and similarly just like this. So okay, we did this as well. We need the fibers to be embedded in the concrete. So to do that, we need an embedded region constraint. So fibers in concrete cylinders, right? And we are going to select the sets. So we have defined those sets there. We have the embedded region in terms of fibers, and we can highlight it here, and we can select this complete cylinder for the host region. Yeah, that's done. And we need to define a coupling constraint for the top. So this is for the top control points or coupling points, and uh, top reference point, and for surface we need to uh, select biangle. I don't prefer selecting a new part rather than I define this uh, as a surface, which definitely I'm going to do. And we have this bottom controlling point, and we have this boss, and then uh, we have this surface, and done and okay. But let's go to assembly back and go to tools, surface manager, and create a top plate surface, right? And you can rename it whatever you want to do with it, and we can create the bottom plate surface, and yeah, and then I came back to this coupling point, and for the bottom control point is okay, surface. So we need to select the surface, that is bottom plate surface. I prefer this way, mostly it's helped me in parametric analysis. So here we have this top plate surface, and okay, yeah, so that's done. And now I need to switch to the load module. So for the load, for the bottom, let's make it something like this. um, it is base reference point, and we should consider them when fixed, right? And for the top, we should consider the top reference point, right? U1, U2, U3, it's okay. And if we go to for the top, if I go to right and edit here, and I need in the negative direction 3 mm displacement or 5 mm displacement, that's okay. So then I can calculate the stuff of the stress strain and all those parameters in the given analysis here. So loads are being done, and I prefer to take a backup from it. So let's make it true, right? And after that, I need to uh, go to the mesh, and for the mesh, um, let's assign them um, 25.4 mesh to see what's going on. That's a very larger mesh, 12.5. That's okay. And yeah, then we are going to mesh them. So meshing has been done, and um, okay, I need to assign them a size of 10 to consider the fibers in it as well, right? So 10 is okay, although if I go to tool and query and mesh statistics, and then I show the entity, it's a very large amount of elements, but let's forget about it. I will try to wait for it, right? And then after that, I will go to the mesh is okay. Mhm. What else is missing? Let's go to job and apply a data check, a quick data check. Call it FRC compression testing, but I should not um make it like this. That's okay. And apply a data check, a quick data check to monitor what's going on in the model, right? Oh, yes, here is a problem. I should go for it. Just in case if you face such kind of problem, you can see here. check that these elements are shown in element missing sections, you can check them. You can check them in your in your results. If I click on it, and you can go there and you can see. Although I remember my mistake that I did not change the element of the fiber, but you can look at here that the fibers have problem, right? I remember it that we have the problem with the fibers. So let's quickly go to the mesh, and inside the mesh, click on the assign property, that is assign element property or type, and go to sets and click on the fibers, right? It will be highlighted here because that option is present here. Click on continue, and when you click on continue, you need to scroll here and assign a truss element, because the problem is there's a T3D2 axial element and we need that. Beam cannot be embedded in the break elements. So yeah, now let's again apply a data check and let's monitor it to see what's going on in this model. Okay, so let's go to the step and the step and with image and concrete. Okay, let's go to first stresses and remove the noises, make it only S because of the nature of the degree of freedom, and go to tools, sets manager, and for concrete cylinder, that's done. With the properties, why I am getting this warning? Oh, I'm sorry. You can see here from the warning I understood what's going on in the model and I got the problem here. Let's apply the same data check again. You also have to carefully monitor your warnings, what are the warnings status in your model. Now you can see we have no other warning except the coupling related warnings, and every other warning is gone here. So you have to troubleshoot your file for every kind of warning before going ahead here. So data check is okay. I will write an input file, and then in the next video, I will try to submit the job for it.